Thank you. Hello, everyone. I'll use this microphone so you can hear me loud and clear. My name is Furmanek, and thank you for coming to this talk. I'm a head of DevRel at Metis, and now we are going to talk for 20 minutes about SDKs and what we do and how to build them, how to maintain them over time. So that is the idea. Before going into lessons learned, etc., let me really quick explain what we were building, because you need to know the context in order to understand why we learned things, etc. So what we do is we build database guardrails. So the idea here is we want to integrate with your developer environment to see how your applications interact with databases. So we can later tell you, hey, is this thingy, your queries, etc., going to scale well when deployed in production? So we basically want to look for issues around performance, schema migrations, configurations, extensions, etc., and use SQL databases. The way it looks, ideally, is let's say that your application exposes some REST endpoint, it's like web app application. We want to integrate with the app and tell you, hey, when someone called this endpoint, this is the SQL query that was executed, okay? This is the SQL statement. This is how the query looks like. But most importantly, this is the execution plan, and this is what we found out. So this is not going to work well in production because it scanned the table instead of using indexes, etc., etc. You may have problems with outdated statistics, with configuration extensions in your Postgres, MySQL, and whatnot. So this is generally the idea. So what we want to achieve is we want to extract the details of your applications based on REST queries. So we want to get the workflow that we executed, etc. We want to get the SQL statement that was executed when you code a particular workflow, whether it was in your unit test or whether you were playing with your application locally. And we want to then project these things on your production database. So we can tell you, hey, locally you have small database with 10 rows, so it's not a problem from the performance perspective. But once you deploy to production, this query won't scale at all because you lack indexes, you have outdated statistics, you use wrong query, you use slow query, CTEs, etc., etc. And the important part here is we want to do that directly in the developer environment. Not in your CI/CD load tests, not very late in the pipeline. We want to do that as early as possible. So that's what we want to do. We want to do that across all the languages. So we do Python, JavaScript, C#, Java, Go, and whatnot. We basically want to cover all the languages, all the databases, all the tech stacks you can think of. For our purposes, we assume that you kind of have some modern application, mostly web application, although we support others as well. It runs with modern CI/CD, etc., etc. So this is where we start. Now, what we want to achieve is we need to do that in an easy-to-use way for you. So you're developers, but we don't expect you to have big knowledge about stuff. And we don't expect you to do many things. It must be as simple as possible, right? It should be no code changes ideally, no database changes, etc., etc. As few dependencies as possible. This is what we want to achieve. So the way we did it, we were working on those things for a couple of years across various languages, and we evolved our solutions over time, and then we learned how to kind of deal with situations like this, and this is what I'm going to share with you. So generally, technically what we wanted to do is we want to analyze what happened in your application, like REST endpoint X has been called, and this endpoint caused this particular SQL query to be sent to the database. We decided to use OpenTelemetry for that. Hands up if you know what OpenTelemetry is. Okay, there are a couple of hands in the air. For those of you who are not familiar, OpenTelemetry is modern standard of defining how to capture logs, traces, and metrics from your application. So basically, it's like a library. You just put it in your code base, and this library takes care of dealing with metrics that you can later browse, search, analyze, etc., etc. So we use OpenTelemetry, which is an open standard, and we want to use OpenTelemetry to extract details of what you did in your application, like the query with parameters, and then reason about this query, how it has been executed by the database. To do that, we basically take the query, we run it in your database, but with the explain keyword. Explain keyword in databases instead of returning the query, like running the query and returning the data, it gives us the execution plan, explaining what happened. Like we scan this table, join it with this table, we join this way using this strategy, these indexes, etc., etc. Then we send all to Metis, to our platform, and you have this nice website that I showed you a couple minutes back, right? So this is what we want to do. And the way we started is we took 3 different approaches. We took approach of like SDK per tech stack, then we moved on to putting more ownership or responsibility on the database, and then moving the ownership onto the developers and other like external libraries. So the first approach we took is, let's take your application, let's add a very tiny SDK of our own. So you basically do pip install Metis SDK. And now what happens is you have your user calling your application. This goes to your web framework, could be Flask, could be whatever. Then obviously you call some business logic that uses your ORM library to talk to the database. You get the data from the database and you return it to the user. And along the way, our SDK integrates with your libraries, so it goes behind the scenes and plugs itself into ORM, into web endpoint, etc., etc., extracts the query, and then runs explain on the database to get the execution plan and send all of that to Metis, right? Simple as that. And it generally worked. It is easy to maintain. Just pip install on your end, and off you go. It works. You don't need to modify your application. You don't need to modify your database. It's great because if you have a team of 5, then only one person on the team needs to do this pip install, commit changes to the repository, and bang, it works everywhere, right? The biggest challenges we had here is we can't reuse this code across languages at all. We need to implement something for Python, then something for JavaScript, then something for C#, and this goes on, and it's hell. But it gets even worse. We can't implement one solution for Python. We need to implement one solution for Python plus Flask plus SQL Alchemy, even worse, in these particular versions. So if you have SQL Alchemy in different version, we need to have different SDK, right? So it's like exponential increase of the numbers of SDKs, and it increases over time like crazy because we need to support all of them. We can't just support one Python SDK. We need to support dozens of them, and over time it will get more and more. So generally there were many issues around how it worked, even though it was very convenient for the developers. So what we wanted to do next, okay, maybe we can kind of limit how many SDKs we need to support and how many different tech stacks we need to support by changing our approach. So we changed our approach to read the details from the database. Remember that I told you on this slide that what we want to do is we want to use the explain on the database to get the execution plan. Can we somehow get the execution plan without running explain at all? The answer is yes. We can ask database to do that. So the second approach is we still drop the SDK on your application, so you do pip install or whatever, but now our application, our SDK integrates with the ORM slightly earlier. It doesn't get the queries afterwards and goes to the database. It goes and gets the query before it is executed and stamps it with the trace ID. So we basically see, hey, this is OpenTelemetry ID of what's going on. We put it on the SQL query. This query goes to the database. And then we have another component that reads logs from the database and reads all the execution plans, right? This is cool because now we effectively do not need to integrate with ORMs per se. We can use dependencies that integrate with ORMs. For instance, SQL Commenter. SQL Commenter can do this magic for us, that it puts the comment on the SQL query, and off we go. So it kind of works, easy to install. You do pip install, you do maintain dependencies the same way. Some problems are still the same. Different SDK per language, different SDK per platform, etc. There is yet another problem or couple more problems with this new approach. First, we need to reconfigure your database to log the execution plans. It is easy, you just tweak the database configuration, but if you run ephemeral databases like test containers, like databases created in GitHub Actions or other CI/CD pipelines, right? Then those databases are very short-lived. You just create the database and it dies a couple seconds later, right? And in order to reconfigure it, we very often need to restart the database. Something that just won't work in those CI/CD pipelines. And yes, we forced it to do, but it's generally hard to maintain and very hard and not very nice to use. Another thing is, depending on your infrastructure, it may be very painful. Like if you run your database in Azure, in AWS RDS, in Aurora, or wherever else, you may have different configuration and it may be hard to reconfigure all those databases. Not to mention that at the very end of the day, you need to log all those execution plans. And if you have logs, then well, they take space. So this increases the cost of your infrastructure, meaning that you just install our SDK, but at the same time you also pay more for logging and for other stuff. So this is not necessarily a good side of this approach. Another problem is, if SQL commenter works, it's all perfect. The problem starts when you do not have SQL commenter in your platform, right? Then we need to go back and implement our solution for stamping the query again, which is kind of slow and inefficient, and we need to maintain so many SDKs. So maybe let's switch gears again. Let's take another approach. And yet another approach we took, okay, move the ownership from our space to somewhere else. We already use OpenTelemetry, and now why not use OpenTelemetry even more? So now notice that we do not have any SDK in your application at all. What you do is you call your application, it goes to the database, gets the data and returns to the caller, all is good. But then we want your application to send the traces to our Metis piece that will just get those traces and go to your database, run explain, and do the magic. Now the question is, okay, but how do I do this? How do I integrate my application with this Metis piece? And because we are using OpenTelemetry, OpenTelemetry has this feature that is called auto-instrumentation. And auto-instrumentation is basically a feature of OpenTelemetry to configure your application from the outside of the process. So you do not need to modify your application at all to send traces somewhere else. So the way you do it is in Python. You just do pip install, you run yet another script from OpenTelemetry, you do these things just once. That's it. And then the only thing you need to do, you just run your application differently. Instead of doing like Python my app, you do this OpenTelemetry blah 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 Python my app, and then all your traces are sent automatically to some piece that sits next to your application, right? So this way, we provide this piece, you send those traces to our application, and off we go. This approach is pretty good because literally no changes to your application, no changes to your source code at all. That depends on the language. In compiled languages like C++, that's gonna be harder. But in Python, JavaScript, no changes at all. No changes to the database, right? But the most important part is this is owned and maintained by someone else. We do not need to build this for every library like separately. We just tell you, hey, use OpenTelemetry, and off you go. And OpenTelemetry maintains their libraries for all the libraries you can think of. And if it's not maintained, if you don't have library for a particular ORM web framework combination, then yes, you can implement that. We help you in implementing that, but technically that is a pull request to OpenTelemetry to do it this way. So generally this works great, and this is what we did, how we switched gears along the way. Now, what have we learned from this whole journey? So generally I group those learnings into like 3 different areas, like how to maintain functionality between those languages, how to maintain versions, and how to deal with the diversity of languages. So the first thing is uniform functionality. So what do we want to have? Whenever we face a case of, I want to have SDK for all the languages in the world, right? What you need to deal with is those languages are different. Some languages are very dynamic, like Python, right? Some languages are kind of dynamic, like Java, for instance. They do have reflection, they can analyze the code in runtime, but still it's kind of compiled language. Some languages are not dynamic at all, like C++ or other Rust, Go, etc., etc., right? So you need to deal with those languages, and you always need to think, okay, do I want to use some fancy features from my language, from Python, which I won't have in other languages, or do I want to implement the code in a very dumb way But then I can just copy this code to other platforms, right? So this is the thing you need to ask yourself. How do you represent structures? How do you represent the API so it's uniform between languages, right? How do you represent the input and output parameters? We know Python, we very often just get the dictionary as a parameter set in our functions, right? Do we do the same in Java? No, they kind of don't do that in Java. So maybe we shouldn't be doing that. It's not an idiomatic code anymore, but maybe it's easier to maintain. So those things you really need to take into consideration when dealing with those multiple languages. And the most important thing that we learned over here is just keep it simple, stupid. Really. Do not go with idiomatic code that can't be translated between languages. Do not use fancy features when they can't be translated between languages. But most importantly, do not own anything. Just use as much as possible of things that are written by someone else. And one example to that is, should we use JSON versus gRPC? And when you think about that, well, who cares? It's nearly the same, right? JSON is the same, gRPC is the same, kind of works. Okay, there are performance issues. One is more human-friendly, the other one is more machine-friendly, etc., etc. But in practice, there is a significant difference between these two. First difference is JSON is merely a definition. And you have different implementations between languages. gRPC gives you the same implementation in platforms, meaning that you just take someone else's code and run it instead of running some independent libraries. And when they tell you abstraction is the king, it's kind of bullshit when we are talking about this space. Implementation is the king. So if you can reuse implementation between languages, just go this way. And that's why gRPC was better than JSON here. Another thing is, should we come up with our protocol, or should we go with something well-known? Where our protocol is great, we send only the data we need, we control the data structures, we don't have any mess over there, and we are really in charge. The problem is we are really in charge. We need to implement all the libraries across all the languages, right? If you use well-known protocol like OpenTelemetry, bang, someone else needs to maintain it. So generally, reuse implementation, not only abstraction. Reuse as much of implementation across platforms as possible. And obviously, it's better when this implementation is provided by someone else. Moving else, how do we deal with versioning? You may think, okay, versions should be easy. I have some versioning, right? Major, minor patch. But now imagine a case, there is a bug in Python SDK, but you do not have the same bug in JavaScript SDK. Do you bump the version in Python? Do you bump the version in JavaScript? And if you keep them not correlated and out of sync, then how do your users know what features you support in this particular SDK version? So what you need to deal with here is first versioning and second testing. For versioning, you need to have two different versions. You need to have semver inside your library, but you also need to have like API version in documentation of your library. Just like when you have REST endpoints and you have versions of your REST endpoints, the same goes for SDK. So what you should be saying is, this is SDK version 2.5.1, which supports Metis version 17. And then you can bump the same version without bumping the Metis version. And this way your users can reason about what's going on. But another thing is you want to have the same tests across all the languages. So even though your implementations are completely different, you want to have the same test cases between all the platforms. If you find a bug in Python, then you implement the same test case in JavaScript, Java, Go, wherever else. Why? First, odds are you have the same bug over there. And second, you really want to maintain one code base of tests. Just one code base that you share across. And in order to do that, you need to obviously have Docker, well-maintained dependencies, strict dependencies, etc., etc. Be explicit about your dependencies because they may cause conflict, avoid any dynamic stuff and whatnot. And obviously, run those tests every single day automatically because they can break just because some dependency breaks, okay? And finally, diversity of languages. How do we deal with that? First thing is, we just can't deal with all the languages. One person just can't deal with all of them, right? There are different structures, different idiomatic techniques of writing the code, etc., etc. Generally, one person won't deal with all of that. What we want to have, or what worked in our case, was having language champions. So you have a language champion for each language, and this champion is responsible for not necessarily telling others, hey, there is this new feature in Python, but how, when I was implementing this thingy, then I had those problems and I struggled with these pieces because of thingy in Python. And then we can discuss that across language champions, and we can then decide, okay, maybe we should not use this particular feature because it won't work nicely across languages. Maybe we should do it differently. So have language champions, let them meet on like a weekly basis or bi-weekly basis so they can share knowledge and discuss how they implemented stuff or how the stuff was implemented, what worked, what did not. So this is generally what we did along the way. To sum up, the less you own, the better. The more external implementation you use, the better. It's like really good when someone else owns the implementation of yours. Do not own your stuff in that case, because then the maintenance kills you. Keep it consistent between platforms. Remember about having SEM versioning and like feature versioning or contract versioning. Test your things early, often with Dockers, with Nix, independently, in isolation, whatever, because, well, you really need to have that to keep it reliable and maintainable over time. Rely on open standards. Do not reinvent the wheel. Do not bring up your stuff, because at the very end of the day, it is you who needs to maintain it. And really, minimizing the scope of maintenance is the key in here. And being all of that said, it's time for Q&A. Any questions? There is one, yes.
So I maintain an API SDK, it's Contra work. What do you think about the prospect of auto-generating such SDKs from, for example, like the API spec?
Okay, so the question is, what do we think about auto-generating SDKs based on some open API specification or something similar? Yeah.
Obviously, in your case, that's not a thing.
Yeah, obviously. Generally, I would go for it. I mean, it's like with gRPC, right? We have one contract definition, we generate it for all languages. The important part is we do not need to maintain it per se. So I'm all for it. That the more you can automatically generate between languages seems like a good idea from these learnings, yes. Any other questions? There is one, yes.
You mentioned gRPC. So I recall maybe a year ago, there was a delay with gRPC library supporting the latest version of Python on Apple ARM. Do you run into those kind of situations where there's just combinations that just don't work and you just have to wait 6 months? So consistent to catch up.
Yeah, so the question is basically about, let's say we use some external dependency, and this external dependency is up to date with new version of Python, but is not up to date with new version of Java or something similar, right? We didn't have this situation for gRPC specifically. We have this situation with OpenTelemetry. So it is that this OpenTelemetry auto-configuration thingy, sorry, not OpenTelemetry. I had this with test containers. Test containers support some things in like Python, whereas it doesn't support some other things about like port binding and exposing things externally in other languages. How do you deal with that? From our perspective, well, either you take ownership, which I do not recommend, or you basically need to deal with this. But dealing with this can be twofold. First, you can go and support those libraries, implement that, do pull requests or whatever else, or you can come up with some hacks in your code base. None of those solutions, unfortunately, is perfect, right? Ideally, you would like to implement the stuff, do pull requests for the library and support it this way, but it's not as straightforward as it sounds, and we all know that, right? Accepting the pull request takes time, etc., etc. So generally, there is no solution to that. You just need to, take the toll of doing that. At least we had to take the toll, and yeah, just wait. That's the only solution for this. Cool. Any other questions? Okay, seems like there are no more questions. So in that case, I'd like to thank you for coming here. Hope you liked it, hope you enjoyed it. Drop me a line, take a look on our webpage, and enjoy the rest of your day. Thank you.